we'll start today with just some basic terms that we're going to use when we talk about functions so that we understand what we're talking about. And when you think of a function, I want you to think of this. Notice the little diagram I put up here, this little cartoon or whatever you want up here. I like to think of that as a function, okay? A function is just some sort of a factory or some machine that you put things into and you get something out of it. So have any of you ever seen, maybe you watch the Food Network or something like that, and you see that they put all these ingredients in the tub and then it goes through all these conveyor belts and it presses them down and at the end you get cheese nips or whatever you get at the end, how do they make this stuff? So I like to think of that as a picture of a function. You put stuff in and then you get stuff out. And what you get out depends on what kind of function you have. So the function you have will determine what it does with your input. Okay? And so think of your input as this. Now this whole chapter we're talking about equations in two variables, x and y, two different unknowns. That's what the whole chapter's about. So think of your input as x. Okay? What you're going to put into your machine is going to be your x. And then you're going to get something out, which is y. Now, of course, you're in math, so we're not going to make cheese nips. We're going to do mathematical operations on what we put in. So we're going to do something to our inputs, and then we're going to get something else out, which will be our y. Okay? And so if you think of it like that, I think it will be helpful. So your x is what you're going to put in, and then your output, your y, is what you get out. All right. I passed out some worksheets, so these study guides will help you. This is what we're going to go through today. And this chapter, there's not a lot, but there are some terms, and you have to understand the terms before you can move on. So you have to be careful. If you're not sure, ask as we go along, because you really need to know what these things mean. Okay? So we start with this idea of a mapping diagram. And if you look at your sheet, it looks something like this, right? You got... Now, you have different numbers here. And it's helpful if we sort of make a machine. So let's make a machine. And so the machine's going to look like this. Y equals something. Well, let's just call it, and I'm just making one up because it doesn't matter, but let's call it x plus 3. So this is our function machine called y equals x plus 3. So a mapping diagram basically takes some numbers, and this is what it looks like on your sheet, right? You got a 3, 2, 1, 0, -1, -2. And those little dots show you that those could go on forever. And so this one down here says D. D stands for domain, okay? And our domain is what the input is, okay? Those are your x values that you're putting into your function machine. And we call that a domain. What you're going to get on your output, your y values on your output, we call that the range. And so we'll use an R for that, and that's why on your worksheet they use a D and an R. And so I'm not going to use the number on the output because I picked one. They just put some numbers here for their mapping diagram, and they didn't tell you how they got there. So I made an actual function, and I took the actual function, and I'm going to do something to my input to get an output. So, Maggie, if I put 3 into my machine here, this is my x values, my domains are my x, my input, what am I going to get on my y's? I'm going to get 6. So 3 gets mapped to 6. That's the idea. Okay? All right, what if I have Sun Young? What if I have 2 in my input into my machine? What am I going to get?
5.
I'm going to get 5. Okay? So that's all that we're doing here. We're mapping these things. And so then you quickly understand that if I'm going to go down 1 each time, so I'm going to get 4, 3, 2, 1. And then these are just going to get mapped over. Okay? And that's what a mapping diagram is. A mapping diagram just simply says, if you put this in, this is what you're going to get out. And it maps it over. So I think the book, it kind of tries to get complicated on you and make it more complicated than that, but it really isn't any more complicated than that. Now, as you can imagine, this is a pretty simple function, right? That's a pretty simple machine. The ones you're going to get, eventually, are going to have fractions and square roots and other things that you're going to have to work with eventually as we go along, but the concept will remain the same. Whatever you put into your machine, whatever your input is, will give you a certain output. Okay? So a function, then, there's the definition. A function is a correspondence And that's all that this means, where you have the arrows corresponding. -2 corresponds to 1 in this function. In a different function, -2 might correspond to something else. But in a function, it's a correspondence between two sets. The domain, our input, and the range, R. And it assigns to each member of D exactly one member of R. This is important. The idea of exactly one member of R is important. That means that if I put any of these into my function, I can't get more than one answer. So if I put whatever number I want in for X, it has to give me exactly one answer for Y. If it doesn't do that, it's not a function. So this is very key.
Wait, say that again?
For every number I put into my domain, for whatever my X is, whatever I put in, it has to give me exactly one Y. It can't give me more than one. If I put in 0 and I get something other than just one answer, then I know that I don't have a function. Okay? All right. Let's look at, and that's what most of these, so we went over mapping, diagram, function, domain, range. The values of a function are the members of the range. These are the values. So they just call that in the book the values of a function.
How do you get more than one answer? Like, it doesn't look like.
In this one you can't because that's a function. In a function you can't get more than one. That's my point. But if I gave you something where you could get more than one answer, then you could have something that's not a function. So do you want me to give you one?
Yeah.
Let me see. What if, all right, what if I had this something like this? Y equals the square root of 4. I'm sorry. I'm giving the exact number, so let me make it a function. Y equals the square root of X. Okay? So, if I can put any number in there for X that would give me 2 different Y's, then I don't have a function. So let me pick a number. What if X is 4? So, what if my domain is 4? What is the answer to that, Jared? What is the square root of 4?
2.
But not just 2. What else? Anybody? It's -2 as well, right?
Oh, yeah.
Because -2 times -2 is 4,
Oh, okay.
right?
Yeah.
So if I put, so this function here, or I'm sorry, I shouldn't say that. This equation here is not a function.
All right.
Okay? Now they're not going to give you that in this section, but I'm just showing that because you asked the question. And in the next couple sections, you will start to get these.
All right.
So that's important to know. I'm going to give you a really, really easy way to tell if something is a function or not a function. It's called graphing it and doing what we call a vertical line test. So if I were, this is from this section, so if I were to graph this graph, y equals x plus 2, what would this look like, Claire? If I was going to graph y equals x plus 2, what would it look like? Okay, so you'd have y-intercept at 2,
Down 1.
and it,
Right.
like this here, a slope of 1, and a y-intercept 2. So it looks like this. Does everybody agree with me? This is what this function looks like. So what I call the vertical line test is very simple. If you graph the function, if you can draw a vertical line down anywhere on the graph and only hit your graph in one spot, you have a function. No matter what it looks like, I'll tell you. If I draw these vertical lines down and it only touches my graph in one spot, you have a function. I'm telling you. I think this is possessed. What do you guys think? This does this all day long. And now it's... All right? Yeah. Let me show you that graph that I was just talking to Jared about. Y equals square root of x. This is what that graph would look like if I was to graph that. So if I was to plug in numbers, if I just picked 0, 1, 2, -1, -2, it would look like this. That's what it would look like. Now notice, if I put a vertical line here, that's going to hit in 2 spots, right? Not a function. So that's not for the next section, but that is a good question, Jared. So that's the idea. A function only gives you one y for every x you put in. Okay? All right. Then it talks about the graph of a function. That's just the set of all the points, x and y, where the x is in the domain, and the function and the rule of the function assigns y to x. That's all we did, was we just graphed that. When Claire just gave us that graph there, that's all we did, was we graphed the function y equals x plus 2. Okay? Arrow notation. Your book uses something called arrow notation, and it's used to describe the rule of a function. It looks like this. It does x, and it uses this arrow, sort of the mapping arrow. And let's just pick something, 2x minus 1. So it tells you, for every x you put in, you're going to put it into this to get your answer. That's all arrow notation is. And then finally, the one that you're going to use most often, and the one that's going to follow you, will be functional notation. Functional notation means this. Any function, we use the letter f, just to denote a function, okay? So if our input is x, which it will be most of the time, you could, if any of you go on to physics or other things, they'll use other variables. But in math, you're mostly going to use f of x, okay? That means that your input, your domain, is x. That's your input, okay? And it equals something. And in this case, it would equal 2x minus 1. Your f of x, whenever you see this, is going to be your y value, okay? This is your y, f of x. In other words, when I put something in for x, and I do the function, this is the function, when I put x into my function, I'm going to get a y. This just means that's what I'm going to get when I put it through the function. Okay? So you could translate this, y equals 2x minus 1. If you wanted to graph that, that's how you would graph it. You would graph y equals 2x minus 1. Okay. Let's see. Example 1. Given the function x, arrow notation, x squared minus 3x, and it gives you a domain. All right. So let's get a graph out. Okay. And here's our arrow notation. X is mapped to x squared minus 3x. And it gives us some domains. And it gives us -1, 0, 1, 2, and 3. Okay? Everybody following along so far? All right, Michael. If I use my input of -1, what's my y value going to be? 1 minus 3 is -2. Good. Does everyone see how I got that? Because if I lost you, let me know now.
4.
Okay? I put -1 into my function. -1 squared is 1. 1 minus -3. Oh, I'm... That's plus. That's why you're confused here. Because it's the wrong answer. -1 times -1 is 1. 1 minus -3. 1 plus 3 is 4. Well, that's why you would be confused. And if you look on your sheet, it does give the point 1,4 there. Okay? So if you kept putting those in, you'd find the points 0, 0, 1, -2, 2, -2, and 3, 0.
Wait, how is 0? I don't remember.
Which one?
0, wouldn't that be -3? Because 0 minus 3.
No, because this is... my paper hitting up there? No, look, 0 minus 3 times 0, which is 0. 0 minus 0 equals 0. So that's what you have here. And then it goes on and it says, graph the ordered pair. And I don't want to spend a whole lot of time on these because I think you all know how to graph ordered pairs. So -1, 4, 0, 0, 1, -2, 2, -2, 3, 0. All right. So it just has the graphs, and it shows you those graphed. And that was B. And so the range. It wants to know, what is the range of this function? Well, if this is the only domain here, if that is the only domain that we're putting in, what is our range? Bethany? If this is our domain, what is our range? The range is the output. That's what we get over here for our y. So the range is just the numbers that you can get. If you put in only those x's, you can only get 3 different numbers. You can get a 0, -2, and a 4. That's your range. Okay? Those are the only possible numbers if you put those in. If your domain was bigger, your range would get bigger. If I allowed my range to be 4, 5, 6, 7, then your range would get bigger. But if those are your only domain, then those 3 numbers are your only range. Okay, let's turn it over to the back. Can someone remind me what time this period ends with the chapel? Because I never know the chapel schedule. 1:50. Okay, we got it.
Wait, so Mr. Sager,
Yeah.
How'd you get 0, -2, 4?
Those are the only values that come up here in your output Y. So that's how we got that. That's our range. Okay. So we're going to do on the back here 1 through 10. So let's look at those. We have function f maps x to 3x minus 2. Guys, on your sheets. Look on your sheets, not talking. 0, 1, 2. So those are our different domains. And how you're going to get these is just to plug those domains into your function. So if I like to do them like this because they're ordered pairs. I just like to put them vertically on top of each other. So if I have a 1, -1, 0, 1, and 2. Well, if I put -1 in here, I'm going to get -3. -3 minus 2 is -5. If I have 3 times 0, that's 0. 0 minus 2 is -2. If I put 1 in, 3 times 1 is 3. 3 minus 2 is 1. And if I put 2 in, 2 times 3 is 6. 6 minus 2 is 4. Okay? And it wants to know, find the range. So these are my ranges, okay? And it wants it in this sort of notation, so -5, -2, 1, 4. Does anyone have any questions on how we get the range there for 1 through 10? Going once? Going twice? Everyone understands that? Okay. Okay. Now it says, in 11 through 20, it just says graph these. So let's graph them and see what they look like. All right. So this one was 3x minus 2 equals y. Okay? And so we have our points. I'm just going to use the same points that we found up here. So -1, -5. 0, -2. 1, 1. And 2, 4. And if I graph that, if I follow that line, it is so that's your line. And notice that in your function, it makes sense because your graph, when you solve for y, is going to give you a y-intercept here at -2. And it's got a slope of 3, which means you rise 3 for every one you go over, which sort of goes right along with what we've learned about the slope. So this particular function, this would be the map. This is what it's asking you to do for 11 through 20. It's asking you to graph those. Okay. Now let's talk about limiting. Does anybody have any questions about the graphing? Everybody understand how I graphed that and how I found that? So if I have this as my function, rather than, what they had you do is they had you put in those x values and then they had you find what the y values are. But rather than do that, if you knew what your function was, I could just draw my line with 2 of those points with my slope and my intercept, and then I would notice for every input I have what I want. So if my input was 3, I would have 7. So that wasn't one of my ones I figured out, but you wouldn't have to figure out all of those if you knew what the function was. That's just an aside. All right, let's do limiting the domain. So the domain are all the possible inputs you can have that'll make this function produce a real number. Okay? So, for example, it gives you some examples. 3 over x squared, x minus 5. and then it gives you 5x squared plus 1, and then it gives you square root x plus 1. And it says, give us the domain. So it doesn't want the range now, it wants the domain. Well, what are the possible inputs that will work? What kind of an answer here would you get here that would not work? Anytime you have a fraction, what can't you have? So give me an idea of what you couldn't have. Well, let me ask it a different way. What kind of a fraction will give you something that's undefined? Which means that you can't have an answer. Anyone?
3 over 8?
Huh? I didn't hear you.
3 over 8?
3 over 8? Well, no, 3 over 8 is a real number. It's just a fraction. What number can't you have in the denominator? 0. Because if you have any 0 in the denominator, you have an undefined function.
Thank you, Ben.
So what do we know? This x squared times x minus 5 cannot equal 0. Okay?
Wait, why can't it equal 0?
Because you can't have a 0 in your denominator here. If you have a 0 in your denominator, this whole thing is undefined. It's not going to give you a real number. You can't ever have a 0 in your denominator. Okay? So what numbers would we put in for x that would give us a 0? Anyone? If you see 1.
1.
I'm sorry? 1? Well, if I put 1 in, 1 squared is 1. 1 times negative 4 would give me negative 4. Negative 4 is not 0. So negative 1 is fine. 1 is fine.
2.
0. Good. Notice that if I have 0, 0 squared, 0 times anything would be 0. So 0 is definitely a number that you can't have. If x is 0, the whole thing is undefined. Because it doesn't matter what this is. If you're multiplying by 0, you're going to get a 0.
5.
5 is the other one. Good, Sung-Young. If you have x minus 5 equals 0, if x is 5, then you're going to have a 0 here. 0 times anything over here is going to be 0. So what is your domain? Your domain is...
So you do not distribute.
Distribute?
Yes.
There's nothing to distribute.
What is that? The x minus.
I'm sorry, that was a 5. I just wrote it. So, guys. So your domain is all real numbers except for 0 and 5. So your domain is every number possible except for 0 and 5 will work on that first one. Okay. Does everybody got that one? Does this make sense to everybody? You can't be 0 or 5. Any other number is fine. 4.99999 is fine. Okay? 4 over 999 squared is fine. The only thing that's not fine is 0 and 5. So when it's talking about limiting these domains, that's what it wants to know. What numbers will not work? All right. What about this one here?
0.
Well, if you have 0 for x, you get 0 squared is what? What's 0 times 0?
0.
Plus 1 is?
1.
So that's fine. X can be 0 in this one, right?
Boom.
Is there any number that x can't be in this one?
No.
No, because there's no number that you could put in there that would give you a 0 in the denominator. If you have 0 here, it works. If you have any positive number, it works. If you have any negative number, it's going to work, because any negative number squared is going to be a positive number. So there's no number you can put in for x. So we call this domain of this one, we call it all real. And I think that's the notation that you use there. All real. Eventually we're going to use a different notation as you go on in the book. But for now, it's all real is your domain. Let's do the last one here. The last one is the square root of x plus 1. So what number can't you have here?
0.
Well, if x is 0, 0 plus 1, a negative number. Right, you can't have any negative number. So x plus 1, guys, x plus 1 has got to be positive. It's got to be greater than 0. Okay? X plus 1 has to be greater than 0. So how do I solve that for x? Subtract 1 from each side. So x has to be greater than negative 1. If I have negative 1 will work, because negative 1 plus 1 is just 0, and the square root of 0 is 0. That's fine. You can have 0. You can't have a negative number. So you can't have anything larger than negative 1. So this is all real numbers except x greater than negative 1. Can you see if I have a negative 4? Negative 4 plus 1 is negative 3. You can't get a square root of a negative number. right? No number times itself is going to give you a negative number. So that's why when you have square roots, you can't have, this can't be negative. So, and I'm sorry about the writing here, it was cramped at the end. All real numbers except when x is greater than -1. Does anybody have any questions on this? What time does this end? I'm sorry. 1:50. So you got 10 minutes. So we'll start working on the sheet. You have your homework. Start working on the sheet. I'll come around if you have questions. I'll help you. So just work on these and try to get as many of these done. You don't have to do the rest for homework. And what you don't finish, you don't finish. But you want to try a couple from each section. That way I can come over and see if you have the right answers to see if you're on the right track before you start the homework.
Question.
Yeah.
Why did that not